Welcome to another episode of Tech Talk Unplugged, where we dive deep into the fascinating world of technology, innovation, and the ideas that shape our digital landscape. I'm your host, and today we're diving into something quite intriguing, VRAMs. So grab your virtual toolbox, and let's explore how we can turn unused graphics card memory into a functional file system. First off, let's address the big question. What exactly is VRAMFS? Imagine your graphics card, that powerhouse responsible for rendering all those stunning visuals in games and applications. Now, what if I told you that there's a way to repurpose the unused memory, specifically the video RAM or VRAM, on that card to create a file system? That's the essence of VRAMFS. It's like having a mini storage unit right under your computer's hood, made of your graphics card's runtime memory. Now, you're probably thinking, why would I want to do this? Well, unused RAM is like idle machinery. It's not doing anything productive. By creating a file system in VRAM, you can actually harness that power. This concept operates similarly to a RAM disk, where you create a fast storage system using system RAM. However, with VRAMFS, you're shifting the spotlight to the VRAM, using it instead of the more traditional memory banks. Let's talk about performance for a second, because that's where this gets really interesting. On the developer system, they reported impressive continuous read speeds of about 2.4 gigabytes per second and write speeds of around 2.0 gigabytes per second. While it may not quite reach the levels of a high-performance RAM disk, it's still quite decent, especially considering that many consumer GPUs come with 4 gigabytes of VRAM or more these days. That opens up a world of possibilities for handling temporary files or data processing tasks that need quick access. Now, moving on to who can actually run this nifty tool, you'll need a Linux system with kernel 2.6 or newer, and your graphics card must support OpenCL 1.2. Don't worry if you're not familiar with those terms. Essentially, if your system is relatively modern, you're probably good to go. Once you've set everything up with the proper drivers and dependencies, it's as easy as running a command to mount your VRAM file system. Just keep in mind that there's a recommended maximum size, around half of your VRAM, because going over that can lead to unpredictable behavior. No one wants their browser crashing mid-session, right? But what happens behind the scenes? The beauty of VRAMFS is in its implementation. Built using the Fuse file system and user space library, it manages user space file operations efficiently, forwarding calls like reading and writing directly to your VRAM. And while the process is largely asynchronous, OpenCL assures that your data integrity is maintained, making sure that writes are completed before reads occur. So you may be wondering about the practical applications. Let's consider a use case. Suppose you're working on a large-scale video editing project. With quick access to frequently used files stored in VRAM, you could significantly enhance rendering times and video playback without straining your primary system resources. Now for the tech enthusiasts out there, think about future developments. There's chatter about implementing RAID setups for SLI or Crossfire systems, which would allow users to harness multiple graphics cards. Imagine the performance boost for heavy data tasks. Before we wrap up, I want to highlight the importance of understanding the limits as well. While VRAMFS can be a fantastic tool, it's not meant for serious, high-volume data storage. It's more of a playground for developers and tech aficionados who want to push the boundaries of what's possible with their GPUs. So as we conclude today's episode, I encourage you to explore how you might use VRAMFS in your own projects. What possibilities do you see for leveraging unused VRAM? It's an exciting world of innovation waiting for you. Thanks.